Good day, everybody. My name is Professor Gordon Brawa. So today I will be teaching you pure mathematics. I'll just pick a random question from integration. This is pure mathematics A level. So I'll just pick one question from integration questions that I have in my PDF. Okay. So I have this question. It just says integrate integral of 1 over 1 plus sine x dx. This is my question. So how do we go on to solve such a question? Okay, so the first thing here, we all did sets in form 3. So the first thing is to find what we call the conjugate. What's a conjugate? A conjugate is just an expression that is similar to another expression, but what will be different is just the middle sign. So in this case, I'll say integral of 1 over 1 plus sine x. Since I said I will have to multiply both the numerator and the denominator by the conjugate of the denominator, here's my conjugate is 1. Then I said we just change the sign of the denominator, the middle sign. So the sign will be minus sine x, close bracket. We multiply by the same thing so that we don't do a favor. Okay. So the next thing I'm going to do now is to expand my brackets. 1 minus sine x multiplied by 1, it just remains as it is, all over. Then if you recognize, this is the expansion of difference of two squares. So I'll just write it as difference of two squares. This will be 1 minus sine squared x dx. Okay, so what will be my next move? My next move now will be changing this denominator into something that I know. Okay, I hope you remember from form 5 that sine squared x plus cos squared x equals to 1. So it means sine squared x is equals to 1 minus cos squared x, and cos squared x is equals to 1 minus sine squared x. So do you see that this is 1 minus sine squared x? What is it? It's cos squared x. So I write 1 minus sine x all over 1 minus, all over cos squared x dx. Okay, so in case you didn't know, dx means just integrating with respect to x. That's what dx means. Okay, so this will be integral. Now what am I going to do? I am now separating these two, 1 over cos squared x. Then I say minus sine x all over cos squared x. I just distributed the denominator between these two, 1 and negative sine x. Then dx is, they are still under one integral. You can also distribute the integral among these two, but in this example I'm not going to do that. Okay, so what's my next move? I'm now going to say integral 1 over cos squared. If you still remember from the identities, this is sec squared x. Then I write sec squared x minus, then this is sine x over cos squared x. Sine x over cos squared x. This is just the same as sine x over cos x times cos x. Okay, so what does this mean? This means that cos sine x over cos x, this is tan. Then what are we left with? We are left with 1 over here. So 1 over cos x is sec x. So we can just write this as tan x sec x dx. I hope you are all moving along with me. Okay, so now what will I do now just to solve this equation finally? Right now, I think you all know that if we differentiate tan x, we get sec squared x. So you must know that integration is the reverse of differentiation. Integration is the reverse of differentiation. So how do we get sec squared x? By differentiating tan x. So how do we go the reverse way? We have to integrate, and if we integrate, we get tan x. So here I have tan x. I have tan x here, then minus. Then you should also know that if you differentiate sec x, if you differentiate sec x alone, you get tan x sec x. Okay, let's just do it aside. Let's do it over here. Okay, so let's say we have sec x, right? We want to find d dx of sec x. How do we go about it? This is equals to 1 over, what did I say? It's 1 over cos, that's sec, right? Then I can say cos x to the power negative 1. How did I go to this? I just bring this cos on top. Okay, so this will be, now let's use the rules of integration. I hope you all know the power rule, the chain rule, and so on. Okay, so we just first write down the power, then we write cos x. After that, we subtract 1 from the power. Negative 1 is negative 2. Then after that, we multiply this by the result of integrating the expression in the bracket. If we differentiate cos x, we have negative sine x. So this will be equals to negative times negative, it will be positive, so it will be sine x. So since this has a negative power, it has to go down according to the laws of indices. So this will be cos squared x. Again, do you see that we have come to this result? We have come to this result. And what did I say? I say this is tan x sec x. Right. So now, do you see how we get this expression? We get it from differentiating sec x. But now, since integration is the reverse of differentiation, we have to do the reverse. So we have to write that expression or that trig that gives us tan sec x after differentiating it. What is it? I said it's sec x. Then whenever you don't have limits here on the integration side, it is called indefinite integration. So you always have to add a constant of integration. You can put a c or a k, but in my case I prefer to put a k plus constant of integration. So for today we are done. This is the example that I find necessary for you to learn. Until we meet again, cheers and God bless. Please don't forget to like and subscribe to my YouTube channel, and also don't forget to ring the notification bell so that whenever I upload a new video, you'll be the first one to be alerted of it. Okay, thank you guys.